longer just with numbers before we add in x's and squares and all kinds of different things that make it more complicated. So we're going to start by dividing the 495 divided by 4. We're going to do long division. So if you forget how this is set up at least, you're going to put the 495 underneath the long division bar. All right, it's not the square root symbol, but it's similar looking. So it's 495 divided by, so that is called the 4 divided by 4. The 4 is the divisor. So you're taking the dividend, 495, divided by the divisor of 4, and we're going to get a quotient. The quotient is the answer. Anyone remember how to do this?
You put the 4. It doesn't tell it one time.
Yeah, you see how many times does 4 go into the first number 4? 1. So you put a 1 up on the top. Now, what you do next is you take this 1 that you wrote on the top and you multiply it by the divisor 4. 1 times 4 is 4. Now, what do you do with those 4s? You subtract them. So you're going to put a minus sign, and 4 minus 4 always gives you 0. That should always cancel out. Now, the next thing you do is you're going to bring down the 9. Now you start the process over. How many times does 4 go into 9? Twice. You put a 2 on the top. 2 times the 4 out front is 8. And you subtract. 9 minus 8 is 1. Now you bring down the 5 here, so you have a 15. How many times does 4 go into 15? 3 times, which 3 times 4 is 12, and you subtract. Now, 15 minus 12 is 3. Do I have anything else to bring down? We could do decimals. We're not going to do decimals because we're going to have remainders here. We're going to have remainders in what we're doing in class. So this 3 ends up being the remainder. Now, when we write the remainder, we're going to write it, since it's a positive 3, plus 3 divided by 4. So it's 123 and 3/4 as the remainder. That's the quotient and remainder. Now, is 4 a factor of 495?
No.
How can you tell? Well, no, that's not how you tell.
Like you already know.
But
No, because it doesn't go into it evenly.
yes, there's a remainder. It doesn't go into it evenly. Right? So no, we could just say there is a remainder. Yeah, I know you can use your number sense, but I'm trying to make a generalization in a minute here. So that's the same process we're going to follow here when we add in some x's and variables and different things. All right, so we're going to do polynomial long division. So being able to divide one polynomial by another could help us for different things, and we're going to learn a faster way tomorrow, but it's going to help us factor and solve the polynomial. In polynomial long division, you must write the terms in order or in standard form. All right, if you're not in standard form, if your exponents are not going from highest to smallest, polynomial long division will not work. So let's talk about how this is going to go. I have the steps written over there off to the side. My suggestion is, at least on the first couple, write down everything I write down. And then you can adjust it based on your needs. But at least for the first 1 or 2, write everything I do. What you do is these steps tell you what to do. We're going to start by basically thinking, you know how in the first problem we said, how many times does 4 go into 4? Well, we're kind of doing the same thing here. How many times does x plus 5 go into 4x squared? Now, here's what we look at when we do polynomial long division. We're going to look at the x, not the plus 5. We're only dealing with the x that's out in front, and to start, the 4x squared. Now, you can kind of think, how many times does x go into 4x squared? But really, let's just think about it as division. What's 4x squared divided by x? 4x. That's how many times you go in. So we're going to put a 4x on the top. Now, formally, we would put the 4x over the x term. If you don't do that, it's okay. But the formal way to do it would be to put the x's over top of the x's. Right? So that's the first step. 4x squared divided by x. Now, we have to write our stuff underneath that we can subtract. So we multiply 4x times x is 4x squared. That goes under the other 4x squared. Now we do 4x times multiply by both terms out in front. 4x times 5 is 20x. Now my suggestion to you is you put all of that in parentheses, and we're going to subtract and put the minus sign out in front. All right, I put the parentheses there because later on if we get other negatives, you want to make sure that you are thinking correctly about the subtraction. All right, 4x squared minus 4x squared. What happens? They cancel. They're always going to cancel. If it doesn't cancel, you did it wrong. 23x minus 20x. 3x. All right. Then you bring down the next term. Now you repeat the process. So we look at the 3x and the x that's out in front. So you divide them. 3x divided by x is 3. So I put a plus 3 on the top. Now I multiply the 3 by both terms out in front. So 3 times x is 3x. 3 times 5 is 15. I put parentheses, my minus sign, and I'm going to subtract. 3x minus 3x cancels. That's what it's supposed to do. Yeah, negative 16 minus 15. Be careful. It's not negative 1. Negative 31. Now there's nothing else to bring down. So this negative 31 is my remainder. So how we write the answer, the quotient and the remainder, there's a line underneath here. This is the quotient, 4x plus 3. The remainder is negative 31. So we put a minus 31 over x plus 5. Now we're going to talk about what that gives us, because we did this long division and I got the answer 4x plus 3 minus 31 over x plus 5. What does that do for us? Well, this is a theorem. It's called the factor theorem. A theorem is a math law. And this law says that you have a factor. We're going to call it x minus a for a general term right now. But something is a factor only if, say this is like x minus 5 right here. Only if x equals 5 is a 0, right? A factor gives you an x-intercept or a 0. Well, basically, x plus 5, does x plus 5 in this example divide the polynomial? Did it divide it evenly? No. So x plus 5 does not divide the polynomial. 4x squared plus 23x minus 16. Therefore, x plus 5 is not a factor. Right? If it doesn't divide it evenly, it can't be a factor. Just like 4 was not a factor of 495. So x equals negative 5, if I use the zero product law, is not a root or an x-intercept of the graph. So we're going to be using long division and then something we're going to learn tomorrow called synthetic division to decide if things are x-intercepts or factors. If you don't divide evenly, you can't be a factor or a root. Right? Flip your paper over. Let's do a couple more. We won't do all the ones on the back, so we're going to be trying your own. We have our next one. X plus 4, we're dividing x cubed plus 2x squared minus 5x plus 12. Now, one thing I did not mention that we have to make sure we pay attention to. We have to be in standard form, so exponents go in descending order, which we have, and you have to have every exponent accounted for, meaning you have to have an x cubed and an x squared and an x and a constant. All right, and we'll talk about what's going to happen here if you don't have that in a minute. Here we're good to go. So we start looking at the x cubed and the x, and we divide. X cubed divided by x is x squared. All right, so I put the x squared on the top. Now what do I do with that x squared? Multiply the outside stuff. X squared times x is x cubed, and x squared times 4 is plus 4x squared. Put your parentheses, and then subtract. When I subtract, the x cubes cancel off. That always happens. 2 minus 4 is negative 2x squared. And then I bring down the next term.
I hate this.
So start over. It's not that bad. You'll like it. So you'll appreciate what we do tomorrow then after you do long division. Because tomorrow is like super easy. It's called synthetic division. It's faster. What? It's going to be combined with synthetic division on Thursday. So yes.
So you have something.
So you got to do it.
We go over this again then?
We're not getting early on the second one. Give it time. You might understand it if you just let me go through a couple of these. Promise you. It's weird the first time. I know it is. The more you do it, the easier it gets. So we divide negative 2x squared divided by x. That gives me negative 2x. I'm going to put a negative 2x on top. I know it's weird, but the more you do it, and just let me get through a couple, it'll start to make more sense. All right, I multiply negative 2x times x. Negative 2x squared. What's negative 2x times 4? Now, here's where you need to be careful. Parentheses and a minus sign.
Oh, because it's minus 1.
So here, my negative 2x is negative 2 minus negative 2. Those cancel. But be careful. Negative 5 minus negative 8. That's like a negative 5 plus 8,
It's 3.
which is 3x. All right, and then you bring down your 12. Lastly, I take the 3x divided by the x. So that gives me 3. Plus 3 on the top. 3 times x is 3x. 3 times 4 is 12. Yep, and then when I put my parentheses and subtract, they both cancel out. So do I have a remainder this time?
I love that.
No. So my quotient is x squared minus 2x plus 3. Since there's no remainder, is x plus 4 a factor? Yes. All right. Let's look at number 3.
So
we're going to look at number 3. Someone was so happy. Okay. I think we're doing number 3. Let me look. Yeah, we're going to do number 3 and number 5. Alright, this one looks a little more challenging because what I'm dividing by, my divisor, is x squared minus 2x minus 4. It's a little longer this time. So I start by still looking at making sure I'm in standard form. I have a 4, 3, 2, 1, 0 is my exponent. So I'm good to start. X to the 4th divided by x squared gives you x squared. Now, I put that right over the other x squared. And you're going to multiply all 3 of the terms in the divisor by x squared. So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And then minus 4x squared. Okay. Minus and parentheses. I know, it takes a little bit.
yeah.
The x to the 4 is canceled. What is negative 6 minus negative 2?
Negative 4.
Negative 4x cubed. Okay. 17 minus negative 4.
81.
Plus 21x squared. All right, then we bring down the next term. All right, now we start over. Negative 4x cubed divided by x squared. Negative 4x. And we multiply everything. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 2x is positive 8x squared. And positive 16x. Parentheses minus. First terms cancel. What's 21 minus 8? 13x squared. And negative 10 minus 16. Negative 26x. And then bring down your minus 52. Last step. Last one here. Yes, thank goodness. 13x squared divided by x squared just gives you 13. So put a plus 13. All right, 13 times x squared is 13x squared. 13 times negative 2 is negative 26x. And what's 13 times negative 4?
52.
Negative 52. Well, what's really nice when I subtract all those?
0.
They all cancel, and I get a 0. So my quotient is x squared minus 4x plus 13, and it's the divisor of factor. Yes, now before we move on, because we're going to do one more together, I just want to make sure you understand what you're actually doing here. When you divide, you're helping yourself factor. So really, what we would get is that x squared minus 2x minus 4 times x squared minus 4x plus 13. That's the factored form of the original polynomial. Because do you know a factoring method to do 1, 2, 3, 4, 5 terms? No. So since you can't factor something with 5 terms, you have to use long division in order to write the factored form. Right? One more. We're going to skip to number 5. Right? I want to do number 5 together. Now the question is, before we start dividing in number 5, are you missing any terms? And we haven't seen, yes, what term are we missing?
3.
The cubed. So here's how we have to write this when we divide. We're going to write our little long division bar. We have to write the 4x to the 4th, but in order to use this method, you have to put a placeholder in for the cube. So we have to do plus 0x cubed.
Oh my god.
Yep. Then minus 5x squared plus 2x plus 4. Why? Because 0, if I don't write it there, 0 is just a placeholder. We have to visually have it there in order to follow the algorithm, which is the pattern, the recipe to do long division. So you have to put the placeholder. What was that? I did get a haircut. Yes. Mostly I just went because I like getting my haircut because they like it for you. So I just decided it was time. What? Downtown 18 to 20 plus. Yeah. I know. I like my stylist. She's wonderful. All right. Last one. 4x to the 4th divided by 2x. Oh, what do we have? 4x to the 4th divided by 2x. 2x cubed. All right. So I put the 2x cubed up here. And multiply. It gives me 4x to the 4th. All right, now here's where we also have to be careful. 4x to the 4th, 2x cubed minus 1 is minus 2x cubed. Never mind, I thought this was a different problem. We don't have to be careful yet. Minus sign in my parentheses. All right, the 4's cancel. What's 0 minus negative 2?
2x.
2x cubed. All right, and bring down your next term. Now, if you're feeling confident here, work ahead of me. See if you can get the answer, or you can stick with me. Either way is fine. Take the next term, 2x cubed divided by 2x. What do you get? X squared. So I put an x squared on the top. All right, that gives me 2x cubed minus x squared. And we subtract. The 2x cubes cancel, and negative 5 minus negative 1. 4. Yep, negative 4x squared. And I bring down the next one. Okay. Let's see. Negative 4x squared divided by 2x. Yep. Using the same color then. It's all right, negative 2x times 2x is negative 4x squared plus 2x. But what happens there when I subtract? It gets me a 0, but I want to still leave a 0x there for a second because I still have to bring down the 4. But what do you think is going to happen when I do the 4? There's going to be a remainder. So if you want, you could put because 0x divided by 2x is going to give you 0. You could put plus 0 up here, but then you're still going to have a remainder of 4. Okay? So what we end up happening is our quotient in the remainder is 2x cubed plus x squared minus 2x. Now, when I write the remainder, I have to do plus, because it's positive, 4 over 2x minus 1. I'm sorry, that's really squeezed in there. So you take what you wrote on the top, 2x cubed plus x squared minus 2x, and plus our remainder, plus 4 over 2x minus 1. And is that a divisor? Is it a factor? No. Okay. So there are 2 other problems for you on there. Number 3 and number 6. Or 4 and 6, I'm sorry. I want you to try 4 and 6. I'm not sure if the answers are on the bottom, but you can check with each other. The key's also on Canvas, but there are a couple more. Go ahead and try those on your own. Tomorrow then, you'll have plenty of time. You will be able to do, we'll shortcut it. We'll make it a little bit easier for you.